You are listening to Astronomy in the Morning on 3995 Lawrence.
Welcome to Astronomy in the Morning on 3995. I am your host, Eric Davis, and we have got a great show for you today. Now, there have been lots and lots of stories out in the news about exoplanets. And it seems like almost every month we are hearing about these exoplanets, and sometimes we're hearing about exoplanets in something called the habitable zones of star systems. So now, what exactly does that mean? Well, first, an exoplanet, that's simply just a planet found outside of our solar system. But what about a habitable zone? Now, with that, they're talking about planets that could possibly support life. Planets that could support liquid water, an atmosphere, decent temperatures, just like our planet. And that is so very cool. And you want to know something that is amazing? About 2 decades ago, people were still doubting whether there were other solar systems like ours. Now astronomers, they're not just finding solar systems like ours, but planets like ours as well. And the search for exoplanets, it has advanced so much in the last 2 decades. The first exoplanets were just being confirmed in the early 90s. Now, astronomers have found 853 exoplanets and expect to find many, many more. My question today is this: how did astronomers get so good at finding these exoplanets? You see, you just can't simply look up in the sky with a telescope and, count all the planets orbiting around each star. You're going to have to be a little bit more clever than that. I'm going to talk about 4 methods that astronomers use to find these exoplanets. I'm going to start with direct imaging. It's pretty straightforward, actually. It's about as close to looking up into the sky and finding planets as you can get. It involves taking infrared images of a star, blocking out the light that the star gives off, and then just finding the planets around it after that. Now, the planets that can be seen using this method are generally going to be a little further away from the star's overpowering light. And these planets, they're going to emit a decent amount of energy themselves, so that the infrared waves will be a little bit easier to see and pick up on. They're also generally going to be a little bit bigger, so we're essentially talking about the opposite of Earth. And today, I'm interested in finding Earth-like planets. And direct imaging, I think, has no real capability of finding a planet like that. I think the next 3 techniques I discuss will be much, much better suited for this task. These are indirect techniques. Astrometry is one of these. It measures the way a star will slightly wobble in the sky, and that wobble is caused by a gravitational pull that the planet would exert upon its host star. And the Doppler method is similar to this, because it measures the way a star moves back and forth, but in a slightly different way. Now, we know the Doppler effect. A great example of that is when a police car with the siren on drives towards us, and the pitch goes up, and as it drives away, the pitch goes down. Light, it behaves in a similar fashion. And now as a star slightly wobbles towards us, the light will shift blue. And as it goes away, it will make a red shift. And we can deduce that something is causing that planet to shift like that, and something is affecting that planet's gravity. And now the last method is the transit method. And that is when a star has a planet orbiting around it, there will be small dips of light when studied very carefully. And that is caused by the planet simply going between it and our planet as we observe it. And each of these methods I discussed, they all have drawbacks. There's no real perfect method right now for finding exoplanets. Definitely. And I'm going to talk about how astronomers can use a combination of these methods to compensate for these drawbacks. Also, we'll discuss the future of exoplanet hunting in the next segment of Astronomy in the Morning, only on 3995 when we get back. We are back to Astronomy in the Morning, the only AM radio show devoted entirely to astronomy. My name is Eric Davis, and we are talking about exoplanets. It is very important to find these planets within our galaxy. By finding an Earth-like planet, studying it will help us better understand our own Earth. As Stephen Hawking, he recently said that he thinks we need to find one to be a new Earth, perhaps someday. Right now, that's a pretty impossible task. Finding one has been difficult enough. I mentioned the 4 methods for finding exoplanets: astrometry, the Doppler method, the transit method, and direct imaging. And the first 3 have shown real capabilities for finding Earth-like planets, but they have some drawbacks. The transit method, for example, in order for that to work, the planet's orbit has to be lined up fairly specifically with Earth from where we view it, or it could potentially skew the data. And the Doppler method has a similar problem with skewing data. But when these methods are used together, they can double-check each other and get a more accurate picture. The Doppler method, it is great at determining a planet's mass because you're measuring the effect it has on the star's gravity. But it's really not very good for telling a planet's size. The transit method, because you're dealing with the dips of light, it does that very, very well. You can discover a lot about a planet by using all these methods together, such as even physical composition of the planet and its atmosphere can be deduced simply by using these methods together. Now, finding an Earth-like planet is very, very difficult, and you have to use a lot of different tricks. And one of the most helpful tricks you can use is launching a satellite up into space to avoid interference from the Earth's atmosphere to get a clear picture and study hundreds of thousands of stars at a time clearly, because one way to avoid error very easily is just to use a larger sample size, and a satellite up in space can just simply get much more data than we can get down on Earth. The Kepler satellite was launched in 2009, and it's been used to find Earth-like planets using specifically the transit method. And in 2013, the Gaia satellite will be launched, and it has the exact same mission as Kepler, except it will be using the astrometry method. The amount of exoplanets, Earth-like exoplanets, and star systems being found continues to increase. As astronomers, they get better at using these techniques we discussed, together and individually. Not only that, but more satellites like Kepler and Gaia are being launched into space to aid them in these discoveries. Now, this is so important, just so important for understanding our planet's past, and really for understanding our future as well. Thank you so much for listening today to Astronomy in the Morning, and we'll be back tomorrow with our special guest, Dr. Tab Shasta. And with that, I bid you a good day.